Hello, this is Mr. Collier, and today we're going to do some measurement conversions. Here we have a metric conversion table here. So we have that kilo means 1,000. That means you do 1,000 times the base unit. So 1 meter would be 1,000 kilometers and such, right? So if you look closely, you multiply when you go up the table. So here to get from millimeters to centimeters, I'd multiply by, and they're different by 1 power of 10, so I'd multiply by 10, or if I go from this step to this step, I multiply by, well, this is difference of 5, so I multiply by 10 to the power of 5, and so forth. And if I'm coming down the table, I need to divide by something, in this case 10 to the power of 3, or divide by 1,000. Alright, and we're going to set up fractions in order to do conversions, in order to do these metric conversions. So I want to change 1 meter into centimeters. So I can start off with 1 meter. If I want to change to centimeters, I want to multiply by how many centimeters there are in a meter. Okay, so we set up like a fraction like this, and then the meters will cancel. Okay, so this is a simple example, but this method is going to help us for more advanced examples. So there's 100 centimeters in a meter. The meters cancel here, and we've got 100 centimeters. Alright, next, how many meters in a kilometer? Well, let's start with 1 kilometer, and then we're going to multiply by, and we need to get rid of the kilometers, and we need to change to meters. Okay, so you can write a fraction like this. So there's 1,000. If you look at your chart, there's 1,000 meters per 1 kilometer. So we do that. The kilometers cancel. We have 1,000 meters. All right. All right. Next we have this. One is scientific notation. So we have 5.8 times 10 to the power 12, and we want and that's milligrams, and we want to change to kilograms. So I'm going to go back to my chart here. So milligrams. Now there's 1,000. Actually, let's look at these scientific notation things here. There's 1,000 milligrams in a gram. So I want to cancel the milligrams, and there's the grams. Now there's so you need the milligrams in the denominator in order to get it to cancel. There's 1,000 milligrams in a gram, so I could put 1,000 down here, or I could put 10 to the power of 3. Okay, and then I need to change the grams to milligrams. So now I need to change grams to milligrams, or sorry, grams to kilograms. We need kilograms. So I need to cancel out these grams, and I need to get kilograms. So there's 1,000, or 10 to the power of 3 grams in 1 kilogram. Okay, so that cancels out the grams. And now I just multiply the numbers together. Okay, so what we have here is actually 5.8 times 10 to the power of 12 divided by 10 to the power of 3 times 10 to the power of 3 kilograms. Okay, so we could write this out in regular notation and figure that out. But actually, if I divide this, it's going to be, let's just simplify the denominator. That is 10 to the power of 6. So when you do this, you divide here, you just subtract the exponents, you get 5.8 times 10 to the power of 6 kilograms. Alright, next example, clock is known to gain 30 seconds every hour. It is set to the correct time at 7 a.m. on Monday morning. What time will the clock show when the correct time is 8 o'clock on Friday evening? Okay, so it gains 30 seconds every hour. So we need to calculate the number of hours from 7 a.m. Monday to 8 p.m. Friday, and then we'll know how much the time has actually changed. Okay, so from Monday 7 a.m. to Friday 7 a.m. Well, from Monday to Tuesday is 1 day, to Wednesday is 2 days, Thursday 3 days, Friday 4 days. So that's 4 days times 24 hours, which equals 96 hours until Friday 7 a.m. 7 a.m. to 8 p.m. is 13 hours, right? So I'm going to add that to my 16 hours and get 109 hours. Okay, so it's 109 hours from Monday 7 a.m. to Friday 8 p.m. and it gains 30 seconds every hour. So now I need to multiply this by 30 seconds. Alright, so multiply that by 30 seconds, I will get 327 3,270 seconds. Alright, so that's how much the clock is going to be too fast by, is 3,270 seconds. So what time will it be at that? Well, we want to figure out how many minutes that is, so we're going to take this and divide it by 60 to figure out how many minutes we have here. So I'm going to do that on the calculator. 3,270 divided by 60. Okay, it's 54.5 minutes. So it's not, so 54.5 minutes. So it's going to show basically that it's 8:54, right? And maybe if there's seconds on there, it's going to be, well, actually that's half a minute, so that's going to be like 30 seconds. So if it has seconds there, so it'll be 8:54. Okay, so next, Effie arrived at Melbourne Airport at 1:55 p.m. and her sister's plane is due to arrive at 15:05 hours. How long will she need to wait? So actually 1:15 p.m. is, if you convert it to 24-hour clock, is 13:55. Okay, so let's look at it this way. From 13:55 to 14 o'clock, which is 2 o'clock, that's 5 minutes. Okay, and then we go up to 15:05. That's going to be 65 minutes. So she needs to wait a total of 70 minutes. Alright, next couple of problems. Petrol oil container has a capacity of 6 kiloliters. That is equal to 6,000 liters. A medicine bottle has a capacity of 0.25 liters. What's capacity in milliliters? Well, take 0.25 liters, you multiply it by, now you put L on the bottom so it cancels, and there's 1,000 milliliters in 1 liter, so you multiply by 1,000, you will get 250 milliliters. Workers at a perfume company need to fill as many 280 milliliter bottles as they can from a 56 liter vat. How many bottles can they fill? Let's change the units first so that we can do this. This is 56,000 milliliters. How many bottles can they fill? They have to divide that by 280 milliliters. Okay. We're going to do 56,000 divided by 280. And you get 200, so they can fill 200 bottles.